Alright, now that we've covered the properties of reflection, let's make these concepts come alive using Desmos, a fantastic online graphing calculator. We'll plot a simple figure and then reflect it across 3 different lines: the y-axis, the x-axis, and the line y equals x. Step 1. Set up your original figure. Open Desmos in your browser. We're going to use a simple triangle. Let's define its vertices and label them. A equals 2, 1, into the first line in Desmos. B equals 4, 1, into the second line. C equals 3, 3, into the third line. Now, to connect these points and form your original triangle, type polygon A, B, C into a new line. This will draw your base figure. Reflection across the y-axis. Our first line of reflection is the y-axis itself. On Desmos, the y-axis is the vertical line where x equals 0. You can even type x equals 0 into a new line to highlight it. When reflecting across the y-axis, the rule is simple. The x-coordinate of each point changes its sign, while the y-coordinate stays the same. So, if your original point is x, y, its reflected image will be minus x, y. Let's find and label the reflected points for our triangle. Type A underscore prime equals minus 2, 1, that's A underscore prime. Type B underscore prime equals minus 4, 1. Type C underscore prime equals minus 3, 3. Now, to draw the reflected triangle, type polygon A underscore prime, B underscore prime, C underscore prime, into a new line. What do you observe? You should see your triangle flipped horizontally across the y-axis, as if the y-axis were a mirror. Notice how the shape and size are the same, but the orientation is reversed. Next, let's reflect our original triangle across the x-axis. On Desmos, the x-axis is the horizontal line where y equals 0. You can type y equals 0 into a new line to make it visible. For reflection across the x-axis, the rule is the y-coordinate of each point changes its sign, while the x-coordinate stays the same. So, x, y, becomes x minus y. Let's define and label these new reflected points. Type A2 equals 2, minus 1, that's A underscore double prime. Type B2 equals 4, minus 1. Type C2 equals 3, minus 3. Now, to draw this second reflected triangle, type polygon A, B2, C2, into a new line. Observe how the triangle has now flipped vertically across the x-axis. Again, the shape and size are preserved, but the figure is now upside down relative to its original position. Our final example is reflecting across the line y equals minus x. This is a diagonal line that goes down from left to right, passing through the origin. Type y equals x into a new line on Desmos to see it. When reflecting across the line y equals minus x, the rule is to swap the x and y coordinates, and then change the sign of both of them. So, an original point, x, y, becomes minus y, minus x. Let's find and label these final reflected points for our original triangle. Point A, 2, 1, will reflect to A3, minus 1, minus 2. Point B, 4, 1, will reflect to B3, minus 1, minus 4. Point C, 3, 3, will reflect to C3, minus 3, minus 3, finally. To draw this third reflected triangle, type polygon, A3, B3, C3, into a new line. You'll see a unique diagonal flip this time, across the line y equals minus x. This visually demonstrates how both coordinates are swapped and negated. By experimenting with these examples on Desmos, using the labeled points, you can clearly see how the line of reflection dictates the orientation of the mirror image, while the fundamental properties of shape, size, distance, and angle measures remain constant. Keep exploring different figures and lines of reflection to deepen your understanding.